Hey guys, how's it going? It's going off grid, and today we got the CNSWIPOWER 2000 watt inverter. We're gonna do a little separate video of this guy, and we got it hooked up to a 1.8 kilowatt hour Mercedes-Benz battery. This comes out of a Mercedes-Benz car. This is a 48 volt battery with 120 amp BMS on top. Bluetooth compatible, so I can read everything on my phone, data, how much power it's using, and we're gonna give this thing a quick try here and see how this thing works. It's got alarm mode on. Okay, that just went off. Oh, interesting. So it doesn't even start putting output power until it checks the alarm mode. I wonder if it actually has a real short circuit protection, just at least initial when you turn it on. I don't know if we're gonna test that or not. We'll see. I might actually test that and see. We'll see. And yeah, we're gonna try running some things with this. All right. So first off, we're gonna start off with this Mastercraft 7.5 amp impact, electric impact, and I'm gonna get everything in frame here. Interesting. It steps it up. Very interesting. It's like the voltage was low then high. That is an interesting way of starting loads. Okay, let's try and reverse just for fun. Okay, so it has a soft start technology in it that it's good because these inverters really, they can surge, and they can design these to surge like a full 4,000 watts peak. They could, but you risk blowing the MOSFETs when you do that. So doing a soft start for a high frequency inverter is actually better, in my opinion, because it's easier on the MOSFETs. All right, let's try something. Okay, so switch cameras. Now we're not using my phone, and this is what the inverter is pulling from the battery. So the battery is sitting at 90%. We're taking 17.9-ish amps. There's your volts on the inverters. It really holds 120 quite nicely. That's sweet. And we're at 48 volts on the input. Temperature in the garage is 7.1 Celsius. And that's thanks to the hot tub that helps warm the place. Now let's go get the oscilloscope and see what this thing looks like for a sine wave with the load and without the load. I just realized I made a little mistake. I forgot I have a charger on this battery here. I have about a 400 watt charger, but once it gets close to 48 volts it drops to about maybe 300 watts or so. So we have almost 6 amps going in. So if you add 6 amps to 18 amps, you get about 1150 watts. This was running, so this was pushing 1150 watts, so that's pretty good. Fans came on almost immediately. It looks like they're load and thermal, which is nice. It's nice to have both, because when you straight up full load this, you want the fans running. So that, I do like that, and I believe that's what they have done, because I don't believe it got warm that fast. They turned on almost immediately and the thing's still cold. So anyways, let's get something bigger. One thing I really wanted to look at was the sine wave when you start large loads, because I noticed it had a soft start feature, and we are going to look at it through this oscilloscope now, and you guys will also be able to see this. Hopefully I can get them both in frame here. You can see them both, the amp draw and the oscilloscope. Definitely see some kickback from the motor, little spikes. Let's see again, how many, I didn't see how many watts it was, but and you can see that the sine wave goes a lot smaller to start the load. One more time. Okay. So that's how it starts loads anyways. let's try something else. Alright, so here we have the compressor we're going to be trying. This compressor, the power jack 3000 watt, could not start. Not very many 3000 watt inverters can start this compressor. This compressor, especially because it's in the cold, has a very hard time starting. Now, we are going to see if this little inverter here will start it. This very well could blow this inverter up, which would suck. But I mean, here we go. Oh, it's trying. Wow, it's got a long cycle to start, that's for sure. That's crazy. How many amps were we pulling here? So it has a soft start where it's not allowing too much power to come out. Because we got 6 amps going in, we're taking approximately 6 amps going out. Try that one more time. There's your sine wave. Kind of goes to a square wave on an overload. Okay, so protection features. I say that worked extremely well, the protections. Here, one second here. I'm just going to give you a close-up of the watt meter here. Got limited room to work with in my garage. Let's see here. Plugging it in. Ha, this watt meter won't even recognize the power. I've been having problems with this, so I'm gonna have to get a different one. But you saw the sine wave, you saw the DC load, so that's very interesting. So it recognizes that there's a load it cannot start, and it won't. It's not even attempting to put out its 2,000 watts because it knows it's going to wreck me. If it tries to put out that full 2,000 watts, it'll possibly blow the MOSFETs. That is really cool to see. I like this feature in inverters myself, just because anything that saves the inverter from dying. So at least if you bought this, it didn't run your load, you're like, ah, that sucks. But at least you have an inverter still. Where if it put out the power, it started it maybe 20 times and then broke, all of a sudden now you don't have an inverter anymore. I do like this better. And we're going to slowly ramp up until we get to this 2,000 watt mark and see if it actually outputs 2,000 watts. Okay, so we still have the charger on. That's why we have 4 amps coming in. And we have 2 plugs here. One is going to a 1500 watt heater, which I'm just going to put straight to high. The other goes to a 300 watt halogen light. And we're going to test the halogen light in the kilowatt meter first and see how much power it takes. Alright, we got 121 volts and 254 watts. It's not quite 300. Everything looks right here. So we were at 4 amps, now we're minus an amp and a half. The light's running. So that's 250 watts. So we're going to take that 250 watts and we're going to plug it in later right there. And then the heater. So this is a 2,000 watt, focus, there we go, 2,000 watt inverter. So this should be putting it right up to 3/4 to 75% of its rating. So let's go with, see if this thing will focus. There we go. There we go. Focus. Here's fan. That's 23 watts. Heat on the lower setting. This heater likes to ramp up. And heat on the higher setting. 700 watts. 900 watts. Inverter fans just kicked in. DC we're pulling, you gotta add, when we get lower in voltage, about 6 amps to this, so we're pulling about 29 amps, 30 amps now. Sine wave is rock solid, looks really good. We are at 1,300 watts. Okay, so this is a 1,300 watt heater approximately. So we got another 250 watts we're going to add right now. If I can get this to go in. There we go. So, got to add about 6 amps to that number, 31, so 37 amps going into the inverter. So we got 1,300, we got 1,550 watts going in with the heater and with the light. I got one more plug available, so I'm going to try and find something else to run. Sine wave again, looking extremely good. Alright, I'll get back to you. Alright, now we got this angle grinder. It is 2.5 amps, as you can see. We're going to start it. It's definitely going to have some sort of a surge, and we're going to come take a look and see what it says. 870 watts there it went up to. Okay, so 870 watts is the surge of this inductive load. Then we got two resistive loads of 1500 watts. That leaves, when we start that, we'll be well over this inverter's limits, and that'll be with an inductive load. So that this thing will not like that. Alright, inverters don't really like inductive loads. So let's plug all this in. Okay, so we got everything plugged in. We're going to start with the light. We're going to turn this onto low first. We're going to try the grinder, and then we're going to switch to high and try the grinder again. So let's see how she works. So I had no problem starting it. It didn't even go into its soft start mode. It just kept putting out 120 volts, which is awesome. So next we're going to put this on high, try it again. And fans are off again on the inverter. So now we're on high. So we're taking 1550 watts between the two. We checked that with the kilowatt meter. Plus, if you add about 6 amps to this number, that'll also give you how many watts we're taking. We're sitting at 47.8 volts, and we're going to try the grinder. Let's see, will she go pop, or is she going to be able to handle this? This should be like 2200, 2300 watts. Here we go. Look at that. Okay, so has a good overload. So we put about 2300 watts on it. It dried for about a second, maybe a second and a half, and then we immediately got this alarm. So we're going to shut it off. We're going to cycle it and make sure we didn't blow it up. It seems to have some sort of circuitry that watches what it's doing. I just overloaded it again. I forgot to shut off the grinder. Well, we overloaded it twice in a row. It didn't blow up yet, I don't think. That's a really good sign. Let's try it one more time. I might actually really like this inverter. We'll see. And you got to remember, we are low. This is most likely designed for 48 volt lead acid battery system, which would normally like to sit at a higher voltage, like 50-ish volts, especially on a large battery bank. But this is showing a very depleted battery. If this was lead acid, inverters have a hard time with that. So I'm going to try turn this to low. I'm going to turn this on. So that's on now, and we're going to go back to high. See what that is at. Okay, everything's on. We're on high. Pulling 34, 35 amps. You got to add 6 amps because I have a charger running into it. So about 40 amps on the DC side. Rock solid on the voltage, on the AC voltage. Sine wave is looking pretty dang good. I've noticed it is showing a little bit more of a flatter curve coming down this side, but very minute. Most inverters, or most generators, I mean, have a really dirty sine wave in comparison to this. This is very clean. Actually, one of the cleaner sine waves I've seen. And we'll just leave that running for a little bit, because this is about 150 watts. 250, so that's 400 watts. And this one was 1300 watts, so we're talking 1700 watts. So we're still under the maximum. It's not even really warm coming out, but it is cool in the garage, so Wow, it's working pretty good. I'm pretty happy with this, to be honest. I'm surprised. I'm surprised with the overload protection, to be honest. Most cheap inverters do not have a good overload and they just blow up. So I'm going to shut this off for now and we're going to find something bigger. The fans just shut off when I shut the heater off, and we're still running about 500 watts. So they're definitely load and temperature sensor, because we saw the thermistor on the inside in a previous video. Anyways, let's find something bigger. Give that compressor one more try to start. Now that we've warmed all the MOSFETs up, this is the best time to kill an inverter. After you just warmed everything up, put a big inductive load on it. That's how you kill an inverter. It's turning. The compressor's turning over, but it will not start it. Okay, that doesn't surprise me at all. 2000 watts really is not enough to start that compressor. Okay, so here are our loads now. We got 250 watts, a little over 1300 watts, about 1315, and now we got this heat gun. This heat gun claims to be a 12 amp heat gun, 750 watts and 1500 watts. We're going to try that. So we're going to try it on low first. Let's see how many watts we take here. That we are at volts here. Let's go to watts. Okay, we are sitting at, this is low, 800 watts at low. And then high, fans came on the inverter, and we're sitting at 1460 watts. Okay, so we know this takes more power than this. Now we got to figure out what this takes. So this takes 460 watts in high. Let's see how much this takes on low. We got everything switched around. We're going to turn this on and see how much power it takes on low. There we are. Focus you. We are at 512 watts. 530 watts. It's climbing. 540. I don't know if you guys can see that. 550. So between these two, we will be over 2000 watts. Let's see what we do here. That's low, and that is high. We are over 2000 watts. Okay, so it ran for a few seconds and cut out, but we were over 2000 watts, which is crazy. So now I'm going to try, stop this for a second. We're going to try this 1530 watts and 250. That'll give us 1530, 1630, 1730, 1780 watts. See if it can power that. There she goes. She's on. We'll just go straight to full. Everything's working fine. We'll just try plugging in the light. Okay, light's on. We're about 1780 watts, 220 watts away from its rating. We're pulling 35 amps plus 6 amps. You gotta add maybe 7 amps because we're getting lower in voltage. The lower in voltage, where, you know what, I'm just gonna take this charger off for a second. Now we can see it. There we're taking 42.43 amps on the DC side at 47 volts. It seems to be having no problems. I'm going to put the charger back on just to help the battery out a bit. Alright, so it's doing pretty good. Let's turn the fan on. So fan's on. We're taking a little bit more power. Let's see how much power we're taking now. We're taking a bit more. Okay, see what else I can find to run. Actually, what I'm going to do now is an overload test to see how many amps it can push. We're going to turn this to high, then we're going to put this to low, and see how many amps we take. So that'll be 2300 watts again, and we're going to see what this goes up to. And we'll watch the waveform at the same time. So on high, on the heat gun, we got fan on the heater. And now overload. Overload, overload. Okay. Oh, I forgot to take this off so you could actually see the actual amps coming out of the battery. We'll do that one more time. This is good, also counting as a stress test, as you can tell, because this inverter has not blown up yet and I keep overloading it, so that's good. It's a testament to the way they designed it. Okay, so it's turning on again. There it goes. Okay, so we got light, heater is on fan, go full on the heat gun. So this is 100% of what the inverter is using. So here is low on the heater. Almost at 50 amps, 49.8 amps. I gotta do some calculations and see how much power it was putting out. Okay, so doing the math, it was running 2340 watts on the DC side, but there is losses in the inverter. So I want to see what the no current draw is. We're going to make sure everything is off. What's our no current draw? Better turn that off. That's weird. You gotta have a current draw. Can't be zero. It's so low that my let's try turning it off again. We're down to 85% after doing all this testing. Wow, the current draw is so low my BMS can't even pick it up. Okay, I'm gonna have to get another meter then. Okay, so impressions for how much it can actually run. So it seems like they really put a limit at 2,000 watts. So 2,000 watts, you got about a second of surge over that, and then she shuts down. We tested it to 1,780 watts, ran it no problem. I didn't have anything to get into in between 1,780 and 2,000. So I don't know exactly where it's going to cut off, but I went all the way up to 2,300 watts approximately, and this thing ran it for about a second or so. The voltage didn't even drop on the output, which was very, very impressive. So it does have a surge, and it seems to have protections on the input when you first plug something in. If it doesn't think you can run it, it won't even try to put out more than, I don't know, 800 or so watts, just because it kind of knows it's just going to kill itself. So I do like those protections. This is actually the most protected inverter I've tested in a long time, which is pretty cool. Come on. At least in the cheap Chinese market, this is a very cheap inverter, very inexpensive, and it performs quite well. Now I'm going to put this into circulation. I'm going to install this in one of my house trailers. I have a smaller house trailer, and that house trailer has 1,000 watts of solar on it, and I actually use it a lot. I use that thing to charge my bigger house trailer, which has no solar on it yet, and keep it everything good in there. Sometimes I run an extension cord to it because I got 4 kilowatts of batteries in my house trailer, and I like free power, so I might be installing this in there, and then we're going to get a longevity test on this, but so far I am impressed. Alright, so we got the inverter apart here. We're going to look inside and see what kind of components we get in here and how this is capable of producing 2,000 watts. Inductor is a tiny bit warm. Not warm, it's actually cold, but I mean it's +7 in the garage, so it's very cold out here, 7 Celsius. So this has warmed up ever so slightly. The output right here has warmed up ever so slightly, and that's where they have put the thermistor. The input also has warmed up, but not as much as the output. The output's slightly warmer. And I actually do like this inverter for its price point. This was $290 Canadian on Amazon, and it seems to perform pretty good for what it is, as long as it lasts a while. We're gonna do some long-term testing on this thing, but I wonder what kind of MOSFETs we got in here. Let's see, does it show at all? No, we can't see it without me really taking this thing apart. But they look like they are the small MOSFETs, which is fine. There's 4 small MOSFETs per transformer, it looks like. 1, 2, 3, 4, 1, 2, 3, 4. Yep, there definitely is. And on the output side, this is where you have your diodes on the back side, I believe, and the MOSFETs are on the front here. The MOSFETs are a larger MOSFET, probably capable of producing more amps for that reason. And you got your what is this? Your input caps here, your output caps here, or vice versa. No, output caps here. Sorry, right here, the little guys are your input caps, and these are your output caps here. These are the high voltage caps that go right before the switching. And the board, nothing special about the board. It's just a nice PCB. There's not too much crazy business going on here. There's a little bit of modifications on the board, but all in all, it's not looking too bad. Similar construction to some other inverters, but this one is obviously designed to actually do its output, so that's kind of nice. Yeah, hope you guys enjoyed the video.